Welcome to Infrastructure as Code presentation. Over the last decade, cloud computing has revolutionized and improved the way organizations procure and manage their IT infrastructure. Also, cloud computing is primarily API driven. So what used to take days and months to procure your infrastructure can now be accomplished in just a matter of few minutes. A big benefit of using cloud is elasticity. So there's no really upfront purchasing, you just scale up and down as and when you need. Now all this is great, but we still have a problem. You may still need to go through your IT help desk or some form of a central team and have them provision your infrastructure for you. And depending upon that particular team's SLA, it could possibly take days to get your servers up and running. Now, this is really okay if you're a very small team and you don't have that many requests, or if your infrastructure isn't changing very much. But what if it's the other way around? How would you go about managing tons and tons of requests? The answer to that is IaC, which is Infrastructure as Code. Infrastructure as Code allows you to manage your IT infrastructure through machine-readable scripts or definition files using the same versioning techniques for the source code as used by the software development teams. Now, if you think about DevOps, DevOps is a movement to reduce barriers between dev and ops. And infrastructure as code helps remove some of these barriers and facilitates collaboration. And it aligns with a key DevOps practice: automate as much of your software delivery process as possible. So how exactly does this work? You basically define your infrastructure, such as your servers, your databases, your load balancers, all as code, and store this code in a version control system, such as Git, and use this code to provision your infrastructure. There are numerous benefits to using IaC. You obviously have more efficient, predictable, and reliable deployments. Without IaC, you would have multiple admins setting up multiple servers. However, with IaC, a single person can spin up hundreds and thousands of servers. And since it's the same code that's used to spin up and set up your various environments, the process is much faster and it's consistent. Also, the whole process of spinning up instances is not manual anymore. Therefore, it's less error-prone. The next benefit is better testing and software control. Since you have codified your infrastructure, you can easily validate and test applications in production-like environments very early on in your development cycle. Another benefit is reduced MTTR, which is mean time to repair. So in case your server goes down, you can use your code to quickly spin up another one. By using IaC, you eliminate the need for documentation. Since your IaC code itself documents the state of your infrastructure, your documentation is always up to date, so there's really no need for any additional documentation. And by versioning your infrastructure code, you leverage all the benefits that versioning offers, such as traceability and auditability. Everyone can see all the changes that are committed in your SCM system. You can easily track the complete history of changes to your infrastructure code, and this is especially useful for debugging any issues. And also, if you need to roll back any of your changes, you can easily do so. Next, let's take a look at some of the IaC tools. IaC tools can be broadly classified into 4 major categories. The first category is custom scripts. You can write your own custom scripts to automate all of your manual tasks. And you can use a programming language of your choice, whether you're using Python, Ruby, or something as simple as a bash script. The second category is configuration management tools. Puppet, Ansible, Chef are some of the examples of configuration management tools. Now, these tools are useful for installing and managing application software on existing servers. The underlying requirement is that you need to have a server up and running to be able to use these tools. Third category is server templating tools. So instead of setting up VMs and configuring all the dependencies on each and every one of your servers, You can actually leverage tools such as Docker, Packer, etc. to create an image of your server. And that image will capture everything that you need, starting from your base operating system, the applications, and any other dependencies that you may have. The last category is server provisioning tools. Now, your CM and server templating tools, they define the code that runs on each and every server. But tools such as Google Cloud, AWS CloudFormation, Terraform, they actually provision every single piece of your infrastructure, starting from your VMs, databases, and many more. That's it in Infrastructure as Code. In my next video, I will talk specifically about Terraform. Thank you for watching.